Okay, so maybe I'll. Okay, so I'm going to be presenting to you the like, basics of Julia and how things work in Julia. Maybe just to start telling you about Julia, you probably know what it is already, but the the idea is to be as fast as C and as simple as Python. This was the goal of Julia, because Python is super nice to play with, but it's very slow, and C is super fast, but it's annoying to play with. So if you go to Julia's website, you get an overview of what Julia is for. One of the strong points of Julia is in machine learning, data science, but also for scientific computing. So you can use it for all kind of things in biology, chemistry, which I'm not familiar with, but I know that it's used a lot in there. So they show you an overview of what you can do with Julia. Just a bunch of things: data science, machine learning. This is probably reinforcement learning. In science, Lorentz attractor, and well, you probably know more about these than me, because I heard that you're all engineers, or at least interested in engineering. My background is in mathematics and data science, so yeah, I know the data science behind it, but for the physics explanations, I won't brag about it because you may know more than I do. So if you go on Julia webpage, under the download Julia section, you can find all the information to download it on Windows, on macOS, on Linux, maybe on APT for Linux users, just in case. Everything I'll be presenting will be fine in 1.6. There is 1.7 available right now, but yeah, you can get either. It shouldn't matter too much. 1.8 is available as well, but yeah, any of these should be fine. So just before starting, maybe to let you know that if you go to my GitHub, which is Joris Limonier, like that, and if you go to repository, there is a GitHub repo workshop getting started with Julia. I haven't uploaded the content yet, but it will be there after the session, and I will complete it probably tomorrow. So make sure to check it out. I did everything on locally, but it's not pushed yet on GitHub. Then if you want the code and everything, you can just download the zip, or if you know about GitHub, you can clone it locally. So that will be added this evening, and then even more tomorrow. Okay, so should dive in, I think. So first of all, like if you've got your Julia set up and installed, you can open the terminal, and then you should be able to type Julia, and then Julia showing up with the logo and here your version. You see I'm using 1.7.1, but it shouldn't matter which one you're using. Okay, one thing that is fundamental for Julia is by pressing the close square bracket. So this key. I hope you're able to see my screen. Maybe I'll zoom in a bit. If you press this key here, it will take you to the PKG, which is the place where you can install all of the packages in Julia. So if you want to add one package, you just go for add, like plots, for instance, which is one package. And for me, it's already installed, so it shouldn't install it. But I guess it's checking for updates. And yeah, so by doing this, so typing this key and then add plots, it should install the plots library, or you'll see for the other libraries. There's also another way to do it, but this is nice because you see the progress as it's going. So maybe just to start with the basics. I'm using a Jupyter notebook inside of VS Code, so to use that, you should just add iJulia, and normally this will allow you to type in Julia. Make sure that Julia is in your path as well, and everything should be fine. So maybe a bit about data structures. Data structures, if I can type. So I'm guessing some of you are familiar with MATLAB or Python, most likely. So just to show you a bit of the data structures that we got in Julia, we've got lists, which are called arrays in some languages. So you can print my list. Oops, print my list, and then it will print your list. This takes a bit of time. It's normal. Julia has quite some overhead. So basically, the first time you launch code, it's going to take a while, like whatever 10 seconds to make a print statement. This is really long. But then when you make operations that take days in Python, they would probably take hours in Julia. So it's probably worth it having this overhead. And then if I run it again, you'll see it's done in 0.3 seconds. So just be aware that it will take a while the first time, but it's normal. So yeah, you can print list. You have a print function. If you do it again, you'll notice that it's as in some other languages, you got a print on which is on the same line. So if you want to print on different lines, you print ln, and it will print in different lines. In Jupyter, obviously, you can also just go from my list, and that will simply display your list as a vector. It's a vector and it understood that it was of type in64. And then you can do all of the basic operations, slicing. So you could do my list of 2, and you will get 2 because 2 is the second value in the array. So just be aware that in languages like Python and C and a couple other languages, these languages would be 0 indexed. So if you type minus of 0, that would return the first element. But in Julia, that gives you an error because Julia is 1 indexed. So the first element is number 1. So this is nice because it's more intuitive, but sometimes it doesn't play nice because of arithmetic operations. So that's how it is. Just deal with it as we all do, I guess. Yeah, you can choose several elements by using this syntax. So this is similar to Python if you know it. So just to structure a bit, that was lists, and then we have. Oops. Okay, and we have tuples, which are similar to Python. So it's like 1, 2, but you can also put strings in there. So bananas and apples, and that would be your tuple. And if you go to my tuple equal, you will get your tuple. And if you want to add something or get something like index 1, you should get apple. But these are immutable. So if I try to if I make a new tuple called my tuple, then this works. But if you try to change the elements inside there, sometimes you'll have issues. So that's all good. Dictionaries. Hopefully there's no typo. So dictionary. So oops, sorry, work properly in dict a goes to 1. Yes, sorry. So you go dict a goes to 1, and then you can add more entries. B goes to 2, which you put inside the dict. And well, if you know, you know. Like, if you, I guess you probably know what a dict is. So my dict equals, and then if you want to access the elements of a dictionary, then you just go my dict of B, and it should return 2, and it does, which is nice. What else we got? So we got kind of dictionaries on steroids, which are struct, mutable struct. Structure types. So like if you go, so you have the equivalent of classes basically, which you can use. Oh, sorry, it was markdown cell. I was a bit surprised that the syntax didn't work. So I don't know, if you have something like a shop, then you can do something like price, and I guess, and probably my shop. Then you made an instance which is called shop, and we can specify the type this way. So price, and what we get, items with array. Where doesn't it want to recall it? Shop. I think you can't redefine it. But, it doesn't matter. It's just about introducing you to classes and kind of the equivalent of object-oriented programming in Julia. So we, like in Julia, there's not the same kind of thing as in Python, which would be like whatever. But can we get some Python here? No. So in Python, you'd go for something like class, my class, and then you would indent that, and you would go for def init, this kind of thing. But in Julia, we don't have this because classes are like the equivalent of classes, which are struct, basically just a placeholder for data in Julia. And so the way you deal to put like different methods inside of your classes is you would use what is called multiple dispatch in Julia. So function, you go for a function which is called my function of a whatever. Then you put your end keyword at the end. This is kind of how it works in Julia in general. Something like this is a, and then you can call my function of whatever choice. This is Joris, so you get the basic things, and then you can specify the type. Oops. You can specify the type in Julia and invalid what you want. Invalid type argument. Okay. Why does it want that? Probably for some reason. Anyway, the idea is that you can give it different types here, and if it might be capitalized. There you go. Sorry, I forgot to capitalize. So you give it the type you want, and basically if you provided something else than a string, let's see how it behaves. So 42. This is 42. So now it accepts it because there's I think because I first defined my function. run all. I first define my function without the type specification. So let's see if now it works. I just restarted the kernel, and let's see if it accepts some int. Now it's running. Let's just wait for 1 second. Okay, there you go. So you see it gives us an error because it knows the function called my function with an input that is a string. And here we give it an input that is an integer, and it doesn't like it. So what you would do in this case, I think it's called method overload in some other languages, is you would define another my function, which is basically the same, except that this time you give it an int, whatever, int 64 or something, and the function, and then you could go for something like println of this is my number, and then you could go for something like a plus 2, right? So now we have a method called my function, which is defined as it takes an argument which is an integer, and now you can perform this kind of operation. Whereas with a string, for instance, it wouldn't make sense. So let's try it. Okay, so you see we have like now everything works. Let's just format it a bit nicer. So this is my number, and then it behaves as you would expect. So this is pretty nice because maybe you want your function and you want it to do something else. So like we give it an array, and now let's try to like adding 2 doesn't make sense anymore, right? So let's give it an array and then something like 42, 46 or something. Does it work? Okay, it works. It behaves properly, and then if you call a function that is meant for arrays. Okay, so you have a collect that is basically the equivalent of in Python, it would be like putting a star, like the star operator, like this. So collect kind of does the same thing. Returns an array when the given type of all items in a collection are iterable. So basically, if you had like sometimes you have an iterator, so you can iterate over it in a for loop, but it doesn't play nice. It doesn't play nice when you try to print it. The way, like by using collect, you can break it into a nice printable way, or you can do other stuff with it that requires it not to be an iterator. Okay, so that's something. By the way, we decided to leave 15 minutes at the end for questions. So around 6:45, I will take your questions. I don't really mind if you have questions straight away and you want to ask them. I don't know if that's a problem, but for me that's fine. Okay, so these are the basics. Okay, I think there's a mic open, maybe, yes. These are the basics. So you like how to make functions, how to make dicts. We can do some math as well. So some math. And so we have all of the basics operations. So I show you already like if you go for a equal 42, and then you can do all of your usual math operations. So a plus 2, a minus 2, a times 2, a divided by 2. Format that. By the way, a divided by 2 gives us a float, which is quite usual in what does the mutable string get errors? I'm not sure actually. No method matching shop. This. Oh, I think. Wait. I'm so stupid. I think I think maybe I just need to provide the arguments. That should work better, I guess. Smart me, right? Yeah, obviously, if you provide the appropriate arguments, then things work better. Sorry. Yeah. So that was for your question, whoever asked. Simon's fun. Okay. Maybe some more operators. So this is the remainder operator. So like 42 divided by 2 gives 21 times 2 plus 0. So that's where we get the 0 here. I'm guessing this double thing is 21. Yeah, right. So this is like a 21 times 2. I don't know what is the slash one though. Okay. So I mean, this is easy to look up. You got quite a good documentation for Julia as well. Julia, I don't know if you composite types. Composite types array. So discourse.julia. This is the forum. You can get all of the answers for whenever you have questions in there. So like asking specific questions, which people will answer in a kind of a Stack Overflow way, or Julia docs array. Just these are the docs. So it's pretty nice. You've got all of the definitions. They tell you like for each type how things behave. Yeah, you can obviously work with matrices, like arrays of arrays, and all this kind of nice stuff that plays well with Julia. So yeah, this is obviously you've got more advanced topics like multi-threading, and you can play with I/O, this kind of stuff. But this is out of the scope of this course, so we'll just move ahead a bit with the next tutorial I wanted to go with. So output, does that work? Okay. So this is so let me just close this. I thought you understood the thing with the package.add, and in case you would prefer doing it inside your cells, you can also do it by this way. So you use package. This is using is like import in Python. I don't know how it is in Java, MATLAB, C. But you can add these packages by passing it a list of stuff you want to add. So for me, normally there's going to be some overhead for the start of the kernel and the start of Julia, but normally it shouldn't download anything, I guess, because I downloaded stuff already. And then whenever you want to use a package, you'll just go with using, and this will call your package. There you go. So that's finished. So this is kind of similar to R, in the sense that like when you call a function like dataset here, you kind of don't know that it belongs to R datasets, but yeah. So you may like it or not like it, but that's the way it is. I personally prefer the way in Python where you specify the library every time before, but that's one of the downsides of Julia. Yeah, so you can use the R datasets like the Iris dataset. I don't know if you guys are familiar with the Iris dataset, but basically this is the like machine learning 101, hello world 101 for machine learning, and data science in general is like so you have these flowers, and based on the sepal length, sepal width, petal length, and petal width. So what is a sepal for those who don't know? So this is these are properties of the flower basically. get some images. Okay, so I think this is the sepal. Like, don't quote me on that. I'm not a biologist, but I think this is the sepal, and then well, you know what petal is, I guess. And based on this, you're trying to classify or categorize these flowers. So you have several species. One of them is Setosa, and maybe I can show you some more. So if I go iris of everything, species not defined. Oh, I guess between quotes. There you go. So you have Setosa, Eugenica, and let me try to get the other one, and vertical one. So you have these three species, and based on that, based on these features, you're supposed to classify, categorize this. So yeah, so this is just a toy data set basically. So to show you some basic stuff on the iris dataset and like some plotting, this kind of stuff. Here I'm using the combinatorics, which is like we'll use it in the cell below, but just to start introducing it. This is basically some, like it gives you some basic results with if you tell it combinations on of 1 up to 4 and 2, it will give you like all the pairs between 1 and 4. So 1 2 1 3 1 4 2 3 2 4 3 4. So it's just to get these kind of nice tools, but it's very basic. I mean, you can do more stuff obviously with it, but yeah, we're just using it for basic purposes here. And then we're using the plots package, which is pretty useful for, well, it's useful for plotting obviously, but like it's super nice in the way that you can choose your backend. So I don't know if they have a list of all the backends, but for those of you that use Plotly, okay, so let me go to. Do they have a link to the docs? Yes, Julia docs. I don't know if they have a list of their backends, but you can basically choose if you want your plots to look like ggplot, like Plotly, like you have a couple more libraries. I mostly use Plotly, so I don't really know about the others, but yeah, you can choose your backend and you can make these nice plots. Yeah, there you go. Dataset series. This kind of same thing as we're doing. So just to show you what you can do with it, you can make all the fancy plots. And yeah, choose your labels, choose your title. We're gonna see that. And you can, for instance, choose the Plotly backend. So Plotly, can we get some docs? Plot the lines, for instance. This is to make line charts. So it exists in Python, it exists in R, it exists in other packages. My internet connection is not super fast, sorry. Python, so you can change that to Julia. There you go. And then you get all of the plots, so for instance, for the scatter plot that we're going to use a bit later. There you go. So you can either using Plotly.js, or you can use plots and then set the backend to Plotly. Right? It's fairly similar. I'll be using plots just because it's more general, and if you prefer ggplot or other backends, then you can change them, and the plots interface will be the same as far as you're concerned. Okay, so back to plots. Oops, the way to use it is super straightforward. So you just call scatter, and then you pass it your whatever variables you want. So here we're using sepal length and sepal width, because here they are, sepal length and sepal width. If you're following along, trying to code along, just make sure that you follow the names, like the Ks and everything, because otherwise I think it won't work. And then if you press enter, you will get a nice plot, which you can improve, obviously, because now we have the legend here. We don't have any title for the axes. We don't know what's going on. So you can obviously set the X label and Y label to whatever they are. In this case, just following this, we know that this is what they are. And yeah, so here you get sepal width, sepal length, and but we still have this. So let's go for legend equal false. By the way, you get booleans. So booleans in Julia are lowercase, so true or false. Yeah, just one thing I didn't present in the previous tutorial, but there you go. And here we remove the legend, and this is what we get. You can play with colors as well. There's a lot of stuff. I'm going to link to some resources in the GitHub repo, so that you can go and check out more resources if you want. There are lots of ways to customize your plots, but I just want to give you the idea. Maybe I don't know. I'll just take a shot in the dark, but lines not space. I don't know how they call it in plots, but like you can make other kind of plots. Histogram. This up with something. Like sometimes you just one capitalization problem or something. Yeah, so okay, probably doesn't make sense to have two axes for histogram, but just to show you that we have other possibilities with plots. So back to scatter plot. This displays a scatter plot of sepal length versus sepal width. There you go. And yeah, so now just to go a bit further, we'll try to make a couple plots, and we'll go through these lines one after the other. So first of all, let's split this, and I'll show you pairs. So pairs is what I showed you before, right? So you get all these pairs of numbers between 1 and 4 included, and you get 2 of them. If I put 3, we get triple. Yes, there you go. And okay, so that was for combinations. And one more thing, maybe just about collect that I showed you before. So this collect thing, if I don't use it, if instead I just go for combinations here, you see we get this thing. So I'm assuming this is because it's an iterator, so it's meant to be iterated over, but not to be used as a whole. I think it saves some memory, and well, I think that's why it's done this way. But yeah, the way to see it is using collect. This way you get to see all of the elements. Same thing as they show here for a range. So if you go 1 to 20. This is 1 to 20, like they're just showing you this, but I'm assuming if I do this, it will actually show all of the numbers. There you go. So this turns it into a vector, which contains int64, and yeah, it's easier to visualize. Okay, so that was about the collect function. It's super useful. Like you'll probably use it quite often, because Julia has quite a few like it's quite you see it quite often in Julia that they use iterators instead of collections like arrays, for instance. And just to tell you about the documentation as well, if you go if you on VS Code, if you hover over the words, you get the documentation, and this here is all implementations of collect. So depending, this is the multiple dispatch we mentioned before. Depending on what you put inside your collect, it will behave differently, and you can get the documentation here, like the definition of the functions, in case you want to check it out. Okay, so back to this. So here what we're doing, we're going over the pairs. So the one I showed you just before. We're grabbing here each like the column of both pairs. Make sure to break this down. So here we go, pairs of one. And then we're grabbing this. So here we're only grabbing columns 1 and 2 because this pair here equals 1, 2. So that's why we're doing it. This named over here is the name of the columns. So here we get the name of the columns, and if we take this indexed by a pair, we get sepal length and sepal width. So these were the first two ones, and you basically cast this to X label, Y label, so sepal width. And then what we do is we select it. So beware that in this case, for instance, the first column is going to be 2 and the second column is going to be 4. So although it says 1 and 2, it's not going to be the first column of the dataset, like the original dataset, but the first column of this dataset we've just selected in this line, right? I hope that makes sense. Let me know if it doesn't. And then we grab the labels, so X label and Y label that we computed just before. And so if we go for that, we get a bunch of plots, and we can actually go for show legend or like legend equal false, just in order to remove the legend. There you go. And so by this way, you can look for correlations in your plots. So here, I would say probably small positive correlation. I hope, well, most likely you guys know what correlations are. I'm guessing if you have a engineering background, that should be easy for you. Yeah, this one has strong positive correlation between petal length and sepal length, which kind of makes sense, right? If the flower is big, I'm guessing both the sepal and the petal will be long. Same with the length and the width, like we're expecting these to be proportional, or like at least correlated. And yeah, so you get a bunch of plots. And petal length, petal width. So there you go. Like you have a couple more stuff you can do with your plots. You can set the background to different colors, as they showed you in the examples here. You can group by stuff, like group by the species, for instance, which gives you like the length, the value for the width and the value for the length, and then you can try to make clusters. I don't know if you're familiar with the clusters in machine learning, but that's one thing you may be able to do. And yeah, just a bunch of fun stuff. Okay, I don't have much time left, so what should we do? What would be better? Okay. Okay, I won't go on the machine learning part because you'll see that next week, and probably it needs a small introduction to before going for it. Just to let you know that like if you go to reddit.com/Julia, I think this is the URL. I'm not sure, but we'll see. Basically, the Julia community is definitely not the URL. Julia. The Julia community is pretty small, so that may sound like a downside because you have less people who may answer, but it's very active and very like narrow, or like it's very much brought together. So most of the time, like every time I asked a question on the Julia subreddit or on Stack Overflow, I had great answers, especially on the subreddit, to be honest. Like great answers, and people really willing to give a hand and help. Very nice community overall. Like it's the kind of small communities that are not yet haven't gone bad yet. Like sometimes when communities get bigger, they get a bit less friendly, let's say. So in this case, it's still a very small community, very nice community. So I would encourage you to post your questions here, post them on Stack Overflow, and I'm sure you'll get answers pretty quick. Okay, it may be also time for some shameless self-promotion. Just to let you know that if you're interested in Julia, if you want to go further in Julia, I have a couple courses or like free lectures here, free videos teaching you the basics of Julia on YouTube. So yeah, you may go here, and do I have the link to my courses straight away? I'm not sure, but on Manning, I have a course on Manning as well that if you still don't have enough from Jousef's awesome couple weeks workshop, you may want to go for that. So just to let you know that this exists, and then obviously you don't have to buy it by any means, but this is the course I propose on Manning. Learn Julia in 3 small projects. We have over 100 people who bought it. So I don't know, if you feel like learning more about Julia, this is I'll put the links in the GitHub repo if you're interested, but obviously this is not the main topic for today. So it's just a small oh, thanks for the link, Jousef. It's just a small information.
Well, I've posted the link to your Manning course in the chat as well.
In the chat. Awesome. Thank you.
Really cool. Also, I think Radmila from Manning, I think we can open the Q&A now, Joris.
Yeah.
Radmila from Manning reached out to me, and I think we'll give away 2 or 3 classes. So it's kind of a prize for participants. So I'm still talking to her. So if anyone is interested in starting with the Julia journey, Joris has some great classes that we will give away soon. Maybe 2 or 3. Let's see. Cool. If you have any questions, feel free to put them in the chat, or just raise your hand. There's this little raise your hand button on the bottom. It's regarding the tutorial, Julia in general. Let us know. Or did you understand anything? Could be a good sign or a bad sign now.
I don't know. Well, anyway, in the meantime, if any question comes up, I would just say that it's super nice for you to organize this, and I saw the program for the other courses, and everything looks super nice. So yeah, I think it's a really nice opportunity for people to learn a whole bunch of stuff about programming and machine learning. It goes quite in depth. So yeah,
cool. Thanks. To anyone interested, I also post Joris' personal space here in the chat. So we'll populate it over time. So I also linked your GitHub repo, Joris. If you want me to put any other links, such as the Manning courses, also just let me know and I'll populate it. And please don't be too shy, guys. Raise your hand if you have any questions. We have 10 minutes left.
I don't know.
I'm adding this one. You're breaking up a little bit, Joris.
Your connection or my connection is a bit unstable, but
I think your connection is a bit unstable. I'm adding the repo right now.
Cool. Okay, we have a question in the chat. What is the main advantage of Julia compared to MATLAB? So stop me if I'm wrong, but I think MATLAB is closed source. Or at least it was pretty hard, at least at some point. I think now it's got a bit better, but at some point it was quite a hassle to reach MATLAB. So Julia, as I showed you, you can just go on the website and download it. So I would say this is like open source, as far as I'm concerned, seems better and more like beginner friendly. And yeah, so I would say probably reaching out to more people would be nice. Obviously, Julia is still very small. So if you go to Python, popularity of programming languages, Julia is still pretty small. It's right at the bottom here, Julia, and MATLAB is way above. But yeah, the fact that Julia is open is pretty nice, I think. In terms of speed, I think Julia is faster, but I don't want to assert. I'm not 100% sure, but yeah, maybe check it out if it's. What's that?
I think it's significantly faster.
Is it?
Probably. I don't have any metrics at hand. Can check.
Okay. It's I don't know if we get to 2 seconds. MATLAB is significantly slower than Julia on simple evaluation. I don't know, just by the titles.
Yeah, Julia's faster. Did I say the opposite?
No, you're right.
Okay.
You're right.
Okay.
Yeah, so I don't know. It seems that it's way faster, but I don't know. Check it out. Maybe it could be useful.
It's also a thread right here that I found. So it seems that MATLAB is a bit slower, to be honest. And obviously, when engineers think about coding like FEM systems or numerical fluid mechanics, I think going with Julia is definitely not a wrong idea.
Yeah.
That's also a question. Is Julia being used in CFD? Because I'm actually following some people. They do their PhD in CFD, computational fluid dynamics, and they start to use Julia more often than MATLAB, to be honest. Julia really has some really great benefits.
Yeah, I think is it Harvard? I'm not sure, but I think this is where it originated. Julia language, and they're using it quite extensively now in this university. I think it's Harvard. I'm not sure, and they're starting to teach some courses in it. So, like no one knows, but in 5 to 10 years, it may be the new Python or something. So it's like if you learn it a bit ahead, you might like it doesn't take much work, and you might be ahead of the competition in a couple years. Yeah, I think it was in Harvard that was invented. Also, I didn't say that, but it was invented by mathematicians. So, in my opinion, you can kind of see the difference. You can notice that in some things they just had in mind that that kind of mathematical mindset I found very elegant. Like when you start coding in it, there are some things that are so cumbersome or heavy in Python that become super nice in Julia. So, I mean, you can't really grasp it just from me saying it, but if you try to code a bit, you'll probably see that.
Absolutely. Also, thanks for sharing the link. Really interesting.
Yeah.
Cool. All right. If there are no more questions, guys, maybe you have some, but if there are no more questions, Joris is also in the community. So if you have any questions for him, feel free to reach out to him in the community.
I'll give my email address just in case, but you can feel free to spam me in emails. I'll be answering as much as I can.
That's good. I'll also add the link to your LinkedIn profile. Maybe you can add it also in the chat.
Yeah, I'll do it.
So let's connect with Joris and learn from him.
I'm grabbing it and I'll send it. Your LinkedIn. Yeah.
Perfect.
Okay, do we have any more questions?
Probably not. Joris, first of all, thank you so much for doing this great presentation. It's pretty hard to do that in 45 minutes, but I think we did great. Also, after the session, guys, you can rate the session from Joris. So please rate the session. You will get a separate email or like a pop-up window somewhere. So make sure you rate the session. I'll forward it to Joris after the session. With that being said, let's close the session. I'll see you guys in 23 minutes with Feline Hermans on how to actually read code. So it's going to be an interesting session. And with that, I'm closing the session. And Joris, thank you so much again. And hopefully see you in my podcast in a few weeks.
Yep, awesome. We'll do that. Thank you everyone for listening, and good luck for the rest of the courses.
Thank you so much, Joris. Bye-bye.
Thank you. Bye-bye.